my experience. Oh, sorry. Now you are recording, Aurelien. So, hey everyone again. And tonight I'm going to speak about my experience with the Hasura end-to-end tests and whatever happened about the Hasura end-to-end test in the last year. So, I think that we can get started. First of all, please keep in mind that the slides that I'm going to present are public. You can find them at this link, so you don't have to take too much screenshots or notes or whatever because they are public. Also, included in the slides, there are a lot of links to a lot of articles of mine. And again, you can find, if you open the slides on your browser, you can also find all the links to the articles. So let's start. First of all, I'm Stefano Magni. I'm an Italian senior front-end engineer. I love my job. I really love to working on the front-end side because there is something new to explore every day, to study every day. And I'm also an instructor, and I actively teach to front-end developers how to successfully test their front-end application. And at the moment, I'm working from Hasura, and I'm in the platform team. If you don't know Hasura, Hasura is a product that allows you to expose GraphQL APIs automatically from your data sources. So you give us your databases, we give you GraphQL APIs with a lot, obviously, of cool features. And also, you can find all my contribution in this repository where I collect all my articles, courses, open source contribution, etc. Since at the moment I don't have a blog of mine, I use this repository to track everything I do. And also, you can find a link to UI testing best practices. That's a sort of small book. It's a collection of articles about end-to-end tests and in general browser testing. And it's my attempt to help other front-end developers jumping onto the front-end testing area in general. Because when I started studying this topic and deepening this topic, I realized that there were a lot of contents on the web, but not so much or much scattered between different tools and practices, etc., about front-end. So, and that's my biggest project. So, and this is because both front-end engineers and QA engineers need to test UI front-end applications in general, but with two different goals. So please keep it in mind. Usually, front-end engineers need to test that the application does what is expected to do. Instead, QA engineers sometimes need to do more exploratory testing compared to proper feature testing. So let's start. So the Hasura console is the main UI of Hasura. So Hasura is by definition a server product, and the console is 270,000 lines of code written in React, TypeScript, and unfortunately also a bit of JavaScript. And it's the main UI product of Hasura. So I joined Hasura in May 2022, and one of my first tasks was to fix the Hasura console end-to-end tests. So what was the problem? The problems with the end-to-end test of the Hasura console. The end-to-end tests are slow in general. We know it's a common problem with testing. Yeah. Also secondary problems, and to test the server, since the server is even in a worse situation compared to the console. When server engineers update the server, they use the end-to-end test of the console to say, hey, if the end-to-end test of the console passed, it means that the console works. If the console works, we didn't break the server. it's not the first time that I meet this situation, but it's in terms of scaling, I think that it's a big problem. So let's speak about all these problems one by one. The first category of problems is the end-to-end tests are slow. So in a lot of tests, all the end-to-end tests of Hasura are implemented with Cypress, and cy.wait is the Cypress way to sleep the test. So in this case, a lot of tests include a lot of cy.wait, wait for 10 seconds, wait for 15 seconds, wait for a long time. And this is a problem because they make the tests extremely slow in general. They are also possibly flaky because think about this. Usually, sleepings in tests usually have to wait for something that happened. For example, server requests. So they, instead of waiting for the request itself, let's wait for 10 seconds. But obviously, most of the time, requests need less than 1 second, maybe. Code start server, sometimes could happen that one request takes even more than 10 seconds. And so if yes, and then another big problem is that sleepings. If I encounter something like cy.wait for 10 seconds in my test, what the author of the test was waiting for? He was waiting for a request to happen. He was waiting for a UI element to appear. What was he waiting for? And so it's for me, the reader, that I'm trying to understand what the end-to-end test does, to wait. So let's fix it. Usually the approach that I follow is to, since most of the times sleep in tests are implemented in order to wait for requests to happen in the front end. The obvious solution is, okay, instead of waiting for 10 seconds, let's wait for the request itself to happen. So if you wait for the request itself to happen, especially in Cypress, but it's the same for other tools, if you wait for the request, Cypress is going to sleep the test only for the time needed for the request itself. So if the request takes 1 second, Cypress stops the test for 1 second. If the request takes 10 seconds, Cypress stops for the really strict required time. But the problem with the console is that in the same page, in all the pages, there is a lot of new code and legacy code with new patterns and legacy patterns mixed together, resulting in different components performing the same request to the same endpoint. And so you don't have the console that performs just one request, and so you can't wait for one request. You can't predict the number of requests every single page does to every single endpoint. And also the order is unpredictable, because if different components with different patterns in the same page perform different requests, you can't know in advance which is going to perform the request first and second. And so this makes extremely difficult to wait for a specific request. Also, the console can use different servers because the console can run in different modes. The first mode is to directly communicate with the Hasura server. The second mode is to communicate with a local CLI Hasura server that in turn communicates with the Hasura server. So there are two different servers, and so it's hard to wait for a precise request because you don't know in what will be this precise request. So the different approaches that I could follow to solve this problem is, the first one is to collect all the outgoing requests and wait for their completion. This is crazy. And in the article that you can find at the bottom of the slide, there is also a long code snippet that allows you to do that. But it's crazy because to implement this, you must do something like, hey, I don't know how many requests are going to happen in the front end. So I wait for something like, I wait for 1 second. I collect all the requests that start in this 1 second. Then I wait for all these requests to complete, and then I proceed with the test. As you can imagine, this is very error prone, and so this is not an approach that I'd like to follow. Another approach is to intercept the same request to different servers, because, for example, if I'm testing that creating an entity works, in the end, it's true that there are a lot of different requests to different servers, but in the end, there are two very important requests, one very important request. The request to create the entity, and could be done directly to the server or to the SI server. So in the end, I can wait for 2 requests, and I know that just one of them is going to happen. Again, this is not something that I love to do. Otherwise, I could wait for something that reflects the response. So, for example, if the console is going to show a success notification after the creation of an entity, I could wait for the success notification to appear. What I usually suggest to other developers is, in this case, to comment in the whys. I mean, if I'm going to wait for the success notification explicitly for up to 20 seconds, it's a very long delay. Why am I waiting too much? Why am I waiting so much for the success notification? Please leave a comment in the code saying, hey, I'm waiting up to 20 seconds for the success notification to appear, because theoretically it could be great to wait for the specific request, but I can't because of this, and this. So that's why I'm waiting up to 20 seconds for the success notification. So the readers, and also yourself tomorrow in 1 year, are going to understand why you're waiting so much for a success notification. And just one last point, sorry. Usually, I like to intercept requests from the client to server, because it could be a really precious source of debugging. I mean, if an end-to-end test is failing, and thanks to intercepting the request, usually I can assert on the request payload. I can wait for the request for the server to respond. I can assert on the response payload. And so if an end-to-end test is failing, usually thanks to intercepting request, I can immediately say, hey, it's the front end that's passing the wrong payload, or it's the server that is passing back the wrong payload. And so this kind of direction helped me to focus on specific problems. And so that's why usually I love to intercept a request in end-to-end tests. Again, in the Hasura console, this is almost impossible. Next big problem, the end-to-end tests are flaky. So let me say that in general, I strongly think that it's way better to have no tests compared to have flaky tests, because flaky tests undermine confidence and trust and add friction to your workflow. Because when you have a test that fails for nothing, it's really boring. You are going to hate tests in general. And I strongly think that if you have a flaky test, fix it. If you can't fix it right now, skip it. Leave a comment explaining why you are skipping it, but remove it from your pipelines. And if you can't rework it, remove it. Again, it's way better to not have the tests, in my opinion, compared to have flaky tests. Unfortunately, in Hasura, this is curious, but because of a big CI misconfiguration, we encountered one problem. A couple of months ago, before I joined Hasura, all the company was complaining about the flakiness of the console end-to-end test, because again, the tests were flaky, so CI pipelines were failing a lot of times, etc., etc., etc. So one good day, someone enabled in BuildKite, we use BuildKite to run our CI pipelines. one good day, someone enabled retryability in build kite. So what was the goal was to, hey, if when the end-to-end test of the console fail, build kite retry again the same test suite again, hoping that the next time the test will success. So it worked theoretically. The big problem was that due to a misconfiguration of build kite and Cypress, what was happening was, let's run the end-to-end tests. The end-to-end tests fail. Let's rerun the end-to-end tests. No end-to-end tests are relaunched. But since no end-to-end tests are launched, no end-to-end tests fail. And if no end-to-end tests fail, CI goes green. So what was happening was that CI went green every time, even if the end-to-end tests were failing every time. And due to this CI misconfiguration, this kind of CI misconfiguration was the worst thing that could happen to us, because you have a slow CI because obviously the end-to-end tests are running every time, but runs one, and also the second time, or better, the first one took something like 10 minutes, for example. The second run, only 4 minutes, because we needed only to install the dependencies to launch Cypress, then Cypress automatically closed, and that's all. So it causes low CI. Tests went updated because since most of the frontenders of Hasura were not using the end-to-end test locally, the only way to detect that an end-to-end test must be updated was the CI failures. But if CI always go green, even if end-to-end tests always fail, tests went more and more updated. So if at the beginning, more or less, only 25% of the end-to-end tests were flaky, only. In the end, after 1 year, more than 50% of the end-to-end tests were flaky, but no one realized it. And also, we as a company were also paying for nothing, because we were paying for BitKite, we were paying for AWS running the tests, we were paying for the Cypress dashboard for having nothing, because every time the test failed, but CI goes green. So we had no value. So this is the worst possible situation about end-to-end tests, but this unfortunately happened. And so this is a problem of, this was the biggest problem with the flakiness of the end-to-end tests. Another big problem. So the end-to-end tests are cryptic. So I think that test code must be 100 times simpler than application code. Usually we write tests, test an application that's complex. So what we must write is not another complex application. We must write a very, very, very simple application. And another strong opinion of mine is that writing tests have 3 main goals. The first goal is the obvious one. We write tests to test features. Okay, that's fine. We all do that. Then I think that you should write tests thinking and easing the reader's job, because in 1 year, again, someone other is going to read your tests, and you must think about how easy your test code to be understood. And also, another very underestimated problem is that tests should be easy to debug. When you write your code test, you must think, hey, is this code easy to debug? If an end-to-end test is failing, here, can the reader that doesn't have the same context I have now, can the reader understand why the test is failing and how to debug it and how to fix it? Usually not. And the main fault of this is abstraction, in my opinion. It's natural that we as engineers create a lot of abstractions. Again, we create complex applications, we create complex abstractions, etc., etc., etc. usually we apply the same logics also to the test code. So if we write a test that does twice the same thing, even if it's just one line of code, we create a function that abstracts away this line of. And this, if we need to have dynamicity in these lines of code, we are going to add 1 parameter, 2 parameters, 3 parameters to this function. But please keep in mind that even low abstraction as a cost, usually we see the cost of duplication, but we don't see the cost of abstraction. And that's a problem, especially with test code. Please keep in mind that if someone is going to read your test, and your test includes a lot of abstraction, who reads the test need to create a mental model about, okay, this function is doing this, calling this function, passing this parameter, and calling this function, passing this parameter. Then return the value to the first one that using this value to call another one. So this kind of mental model it's really gets in the way of debugging tests in general. And also, please keep in mind that end-to-end tests are very, very hard to be debugged in general. You have your front-end application that talks to a real backend application with a real database. The front-end application runs inside the browser, and you have a tool that controls the browser, and you have your code that instruments the tools that control the browser. So there are a lot of possible failures and source of problems with this complex stack. And so that's why, at least with your code, you must try to keep your code as stupid as simple as possible. And I have some examples. I hope that you can read it well because of the streaming. I hope the quality is good enough. This is a piece of a test, an end-to-end test of Hasura, and you can find the test definition at the top. The test definition calls another function that in turn, this function calls a lot of other functions, okay? Sometimes bringing values from centralized objects. So this is what I mean for abstraction is a problem with tests. I mean, in the end, this code is very simple, okay? If you spend 1 minute, you're going to understand it. It's not a problem. But this is just a short piece of an end-to-end test. And if I need to read 50 functions like this, in the end, I need to understand, maybe I take 15 minutes to understand what the end-to-end test does. But why? Please keep in mind that if you are the author of the end-to-end test, okay, you have the context, you understand it, you are writing this code. But if this end-to-end test is failing, and I need to debug it, I don't have your context. Why have I to spend 50 minutes creating a mental model of all the abstraction chain to understand what the test does? I need to debug the test. Okay, I need to fix the test. I hate this kind of abstraction. And also to give you a business example of what I mean for abstraction is not good in test code. The next code, does exactly the same without any kind of abstraction. I think that this code is better for end-to-end tests because this code is stupid. This code is imperative. If you read the code of the test, you don't have tabs. Okay, you must know how Cypress works, but in the end, you don't have tabs here. There is no function. There are no centralized objects. It's stupid. You don't have surprises. This is the code that I expect in a test. Okay, even if this requires a bit of duplication. Again, duplication has a cost because it can go outdated during the time, but it's stupid. Everyone understands duplication. And so this is the kind of code that I expect to see in a test. Obviously, this is not a rule of thumb for everything in general. And I think that abstraction is good in tests, where hides workarounds, I'm going to show you an example, and when they are very soft abstraction. So For hiding workaround, I mean something like this. So I created this abstraction in the end-to-end test of the Hasura console because, unfortunately, we have a lot of code editor inside the front-end application, and unfortunately, Cypress doesn't work well with these code editors. So in order to clear the text area, you can't use the Cypress idiomatic way to do that. You can't use cy.clear, but you must use this kind of combination of selector and trigger down, etc., etc., etc. This is the kind of abstraction that, okay, it's fine if you abstract it away because it doesn't make sense to repeat this 10 lines of code a lot of times in your test. And also, again, it's a workaround. You don't care about how it is implemented. And if the test is going to fail at this point, this function is harmless. It's stupid, imperative, just 10 lines of code, no parameters. Okay, that's stupid code. If I find an abstraction like this, for me, it's good. Another example is this again is another utility coming from the source of the code at the end test of Hasura. And originally, we had one big expect notification function that aims to centralize whatever kind of end-to-end test check for the notifications. The problem with the first function, I hate it. I hate it because it accepts a lot of parameters. It includes if statements into the code, and when you have to debug end-to-end test, if statements are crazy, because in order to remember, I know that the function is stupid itself, but in order to remember if the test is failing here, in order to remember what's happening, I need again to create a mental model of, okay, my test is going to call this function, calling this function with these parameters. So theoretically, this if statement was, I'm not sure about that. Why? I hate this kind of abstraction. This is the kind of abstraction that I want to see. I want to see a lot of stupid, short, small vertical function. So instead of having just one big expect notification function with a lot of parameters, I want to have 10 vertical functions. Expect success notification, expect error notification, expect info notification, expect info notification with text. This kind of stupid function, because again, if a test fails here, the code is so stupid that I can't debug it. Okay, I know that in this case the function has a parameter, but it's just one. It's harmless, and this function doesn't include if statements. So this is the kind of abstraction that I think that's good in the tests. Also because, for example, recently we completely changed how the notification library that we use. And so fixing the test is just a matter of finding these small functions and fix them. And another thing that usually I suggest to all the frontenders writing tests for Hasura is to have a match between code. The test Cypress includes this super useful test runner, okay, that logs every command that you run. The problem is that, okay, I have a log for every command, but this is sometimes it's not helpful. For example, if I have a function that performs a lot of commands, in the end, in the log, I have all the commands listed. But for me, the reader, it's hard to connect all these commands to that function. I need to call the function to read the function code, etc., etc., etc. What I suggest to do is to add a lot of logs to let the reader understand what the application is doing from a product perspective. So in this case, I don't know if you can read it, but I suggest for every 1, 2, 3 commands to add a log that explains to the reader what I'm trying to do. The author of the author of the test, I'm doing this, and this is I'm typing into the action definition text area. And then I have a lot of Cypress commands. Then I'm typing into the type configuration text area, Cypress commands. This allows me to first of all, understand from a product perspective what the end-to-test is doing. Second, it allows me to immediately link the what happened in the test runner to the code. And so this is something that I think is really cool. Tools like Playwright, Storybook, etc., usually have dedicated APIs for doing that. It's called STEP. So in Playwright and Storybook, you have the STEP API that allows you to do the same. In Cypress, you don't have them, but again, it's just a CY.log call. Another suggestion of mine is to use clear selectors. This is an example, again, from the Hasura end-to-end tests. So maybe the author of this test, when they were testing the application, maybe they don't have a better way to retrieve the first text area from the page, if not by getting all the text areas and extracting the first one. Makes sense. Okay, I don't complain about that. What I complain about is that from a product perspective, these lines of code and don't tell me anything, because okay, you are retrieving the first text area, but what is the first text area? I mean, if the interface is failing and is failing here, and if the UI added more and more text area, you cannot be sure that the end-to-end test works. And if I need to debug the test, it's hard to understand what was the text area that you were trying to retrieve from the page. So if you don't have a better way to retrieve the text area, at least, okay, you can retrieve just the first text area that you find in the page, but please give it an alias, give it a variable name. So in the end, I know that if the end-to-end test is failing and text area change the order, I know that what the author of the test was trying to do was to type into the action definition text area, not a generic text area. And so I can maybe fix the test in a while, but maybe I can save a lot of time. And then there are, if you notice, every slide has an article at the bottom, and the article is not the same for every slide. So if you want to find more suggestions about this, please go to the article of mine, and because there are more opinionated but longer to explain things that I shared in the article. Like, for example, reducing the usage of data test ID attributes and to group related actions. Then, next big problem, debugging the end-to-end tests is challenging. So, a question for you. In general, what do you prefer when you write end-to-end tests? Do you prefer a lot of small but dependent end-to-end tests, a lot of small but independent end-to-end tests, or one long end-to-end test? So, let's speak about all the examples and the pros and cons. If we have this is the Hasura Console situation, a lot of small and dependent tests. That means that the test to create and to modify an entity takes for granted that it's run after the create the entity test. So the first test create the entity, the second test modify the entity, the second test delete the third test delete the entity, and that's all. They are three tests, but they are strongly dependent among them. In general, having dependent tests that depend on the order is an anti-pattern. It's a source of a lot of problems with end-to-end tests. It's impossible to run them in isolation, and this is another big problem, because if the second test is failing, I cannot run only the second test. I need to run the first test and also the second test, and also give a fake sense of the size, because you can find a test and say, okay, it's quite limited. No, it's not limited. Maybe it's the sixth test of a long row of tests, and so it's not a small test. So small and dependent test, again, is it's the Hasura Console situation, and it's something like, okay, let's start, and the application state is empty. The first test create the entity, the second one modify the entity, the third one delete the entity. At the end, the application state is empty again, and we can restart the test again. It's a big source of problem. Ignore it at all. If you had this situation, please let me know, especially if you don't have problems, because I'm curious. So let's talk about the second option. having a lot of small and independent end-to-end tests. In this case, I can run the test in isolation, and this is truly very important when I need to debug tests. It's a best practice, and it's a best practice for a lot of reasons. And the problem, unfortunately, is that making them fast requires a lot of boilerplate. Why? So let's try why making small end-to-end tests like create, modify, and delete the entity is so boilerplate if we want to make them fast. I mean, if they are independent, it's good, but they are slow. Why? They are slow because every test should if we keep the test independent, every single test is going to, for example, load the page, create the entity, delete the entity, because the test must be independent. The second test, the modify the entity, must do something like, hey, let's visit the page. Oh, sorry, let's create the entity. Let's visit the page. Let's do the test, and then let's delete the entity. The problem is both create and modify need to visit the page. And in the case of the console, now the situation is better, but until 1 month ago, the console required 10 seconds to load. And so if 3 tests are going to load 3 times the same page, we are going to have very slow tests. If I don't want to have them so slow, I need to implement the test in a way that they could run in isolation, but also to use the previous application state. This is an example. So this is the standard way to do something like small and independent end-to-end tests. If you read it, the first test, it's the test about let's create the entity. So let's load the page, let's create the entity, and let's delete the entity, because the test must be sure that the next tests won't fail because of a dirty application state. The modify the entity must create the entity, because we need to have the entity to modify, to load the page, modify the entity, and delete the entity, etc., etc., etc. Again, these kind of tests are perfect from a theoretical perspective, but in the case of the console, it means that the test took twice the time as the first ones, the small but dependent end-to-end tests. And what we can do to make them independent but also fast? What we can do is we must be sure that every test can run in isolation, but when we run all the tests in a row, we must implement the test in a way that if the test comes after the first one, let's not reload the page, let's not delete the entity, let's not create it, but let's use the previous application state. Something like, this is the test for the modify the entity, okay? So the test that modify the entity must do something like, hey, does the entity exist? If yes, because I'm the second test, because before me, maybe they create the entity test 1, that's perfect. I keep that application state, I keep the entity. But if the entity is not there, I must create it. Okay, that's perfect. Then, okay, now the entity exists, but doesn't the entity already include the change that the test is going to do? Yes, I must revert this change. Otherwise, no, that's fine. Then, are we already on the correct UI page? Yes, let's stay here. No, let's load the page. This is complex, it's going to add a lot of complexity and a lot of boilerplate. There are plugins that allow you to do that, but in general, this is the source of a lot of boilerplate, because you are going to spend and to write more code with the boilerplate to do that compared to the test itself. Also, in order to make it very fast, you need to perform a lot of actions to API. If you do a lot of actions to API in the end-to-end test, you are going to have a small application in the end-to-end test that do all this kind of API requests, and you have to maintain it. So when I implemented it in the Hasura console, I realized that it was not the best way to do that. The last option was just to have one very long end-to-end test. The problem is it's very long. It's not modular, so I can't split, create, modify, and delete the entity, but at least it doesn't lie. It's long and it's there, okay? And if in the end, if we create just one long end-to-end test, it's like having all the advantages of the first option, the small but dependent end-to-end test, because it's faster. And also I have one independent test. Okay, you can argue that it's really independent because yes, it's independent because it's super long. But in the case of the end-to-end test of the Hasura console, I strongly prefer to do that by leaving a lot of comments, etc., because again, we are speaking about a test that takes 20 seconds to complete. But when I implemented the small but independent test, I had to wait for 1 minute because of the continuous console reload. And so the answer is not guaranteed. In the case of the Hasura console, I implemented it. But again, this problem in reality comes from the nature of the end-to-end test. The real problem is not short, independent, dependent, or long test. The problem is the end-to-end test, the end-to-end nature of this test. What I usually do is to write only a very limited number of end-to-end tests, only for the happy paths. Then I prefer to spend, because of these problems, then I prefer to spend my front-end development time with server-free tests because are faster, because application state is not a problem. If I don't have the real server, the application state is not a problem. I don't care to need to check if the entity is already there because I need to modify it. Hey, I'm working without the server. I don't have application state. And the only problem is that how we usually implement server-free tests. You usually implement them by using static fixstacks, static responses. So instead of having the real server, you use static JSONs instead of the server, and you instrument Cypress to give back these static JSONs to the UI. Obviously, these static JSONs can go outdated compared to the server. So this is the cost of having server-free tests. TypeScript helps a lot, and I'm going to touch this topic again later. Another big problem, the server teams use the end-to-end test also to test the server. And this is a problem because for every server change, they check again if the end-to-end test of the console works, and they are sure that the server works. But due to the CI misconfiguration, this kind of security was completely, and confidence was completely false. And in general, I strongly think that the kind of front-end tests must be split, because when you have a small product, who cares about end-to-end tests of server-free tests or UI-free tests? Who cares? We need to test everything. But this solution doesn't scale when you have such a big application like the Hasura console. And splitting server and console tests allow the server to have UI-free tests and the UI to have server-free tests. And they are super fast, both of them, especially for the server, because on the front-end side, we are already used to load the browser. But on the server side, maybe a lot of small integration tests are 20 times faster than a browser. And the article that I share at the bottom of the slide is the contract testing proposal that I did internally. And the contract testing proposal was essentially to decouple this kind of tests. The server must test itself against a fake UI. And the fake UI is just something that performs API requests. So the goal is, if the requests are made in this order, and this order is the console order, the server must work. That's perfect. At the same time, the console test will be run against static responses, and the goal is if both the parts of the stack, front-end and backend, respect their part of the contract, they are going to work also together. So you don't need to have end-to-end tests. You can spend your time writing integration tests. This is more or less the main things that happened in 1 year of work on the end-to-end test of the Hasura Console. And we did a lot of things in general, and unfortunately, most of them have not been completed because I started refactoring all the end-to-end tests, but I never completed it. I introduced the contact testing proposal, but I never pushed it so much with the server forks. I fixed the CI misconfiguration, but in order to fix misconfiguration, we need to exclude the flaky end-to-end tests. I started excluding some end-to-end tests and tracking which are the flaky ones. Again, a lot of work. Then, again, I refactor end-to-end test, but not completing it. Track and skip the end-to-end test without completing it. I asked the feature teams. Remember that I work in a platform team, so I don't implement features. We have feature teams and we have a platform team, and they work in the platform team. So every time I found a flaky test, I had to ask to the feature teams to fix it. So in the end, also because of a lot of CI pipelines problems that we had, we came out with a real strong decision. And this is the changes introduced by a PR of mine that came to me, that has been merged 2 weeks ago. And I completely deleted from the code base every slow and flaky end-to-end test. Please note that removing the slow and flaky end-to-end test from the Hasura console mean removing all the end-to-end tests. I removed 95% of the tests. Now we have just 11 end-to-end tests, the one that was running perfect every time, the one that includes just smoke tests to be sure that the console from a high-level perspective works, but I removed all the other tests. We had 200 end-to-end tests, now we have 11 end-to-end tests. I completely removed them at all. They were a constant source of problems, and we don't have time to waste with them. Okay, so what's the future? I mean, I know why end-to-end tests are important. I prefer to have end-to-end tests for our product. Now I removed them. So in the future, maybe we are going to create a lot of plugins and add-ons for Storybook in order to allow the front-enders of the feature teams to test their components and their views and pages inside Storybook. Since it's something that they are already doing, we need to push to write more Storybook tests that are faster, more reliable, and without a server. A game changer for us is that the server will generate the TypeScript types for the APIs. This is super cool because until now, obviously, in the front-end application, we have types for the server requests, payloads, APIs in general, but they are maintained by the console folks, so they could not be correct. Also, if you think about the tests, until now, I try to push you the idea that we should write server-free tests. In order to have server-free tests, I also must be sure that the static responses, static JSONs that I use instead of the server are typed and aligned with the server ones. So I can improve how we test front-end applications, but at the cost of not being sure that these kind of tests are aligned or not with the server. But if the server generates the types for us, that's perfect because I don't have to check about, hey, is the front-end types aligned with the server? I don't have to do that because they are aligned, they are created from the server. Is the request payloads correctly sent by the console? Hey, if the front-end respects the types, that's all. I don't have to care about them. Are the JSONs aligned with the server? I must only be sure that the static JSONs are typed correctly, but I don't have to think about, hey, this static JSON can be outdated compared to what the server does, etc. So in terms of confidence, in terms of testing, having the TypeScript types generated by the server is a true game changer. Also, maybe in the future, we are going to use Playwright instead of Cypress because Playwright improved a lot. It offers a great developer experience in general and requires less resources, and it's way faster. So at the moment, we are not investing so much in end-to-end test. But when some front-enders of some feature teams want to invest in end-to-end test, maybe we are going to push them to Playwright instead of Cypress. And please stay tuned because this is our current situation. This situation is going to evolve. This talk is a summary of what happened in the last year in Hasura for the console end-to-end tests. And if you're curious to read more or if you missed something, I just shared with you the written version of this talk because I created an article before last week before preparing the slides, and then I converted the article into this presentation. So stay tuned because again, the situation is going to evolve in the future, and I think that I don't know, in 6 months or maybe in 1 year, I will have more and more news about that. And so thank you so much. Thank you for attending the talk. Thank you thank you in advance for all the questions that you have. I hope you have a lot of ones. And if you need the link to these slides, okay, here they are, and you can find all the other links that I shared with you during this presentation. And so that's all. Thank you, folks. And do you have questions?
Thank you very much, Stefano. It was very, very interesting, super nice. From the chat, I didn't see any question, but okay. I will start, and if there are people, they can directly unmute themselves or write in the chat. One question I saw you didn't go in detail about it, you just mentioned it, but out of curiosity, why would it be wrong to use too many data tests?
Okay, that's a good question. For 2 main reasons. First of all, I think that tests are way more stable if you don't test your application as a developer, but if you test your application as a user. What I mean, only a developer is able to retrieve a UI element through a data test ID attribute, not a user. Okay. If you think about that, if you think about a registration form with email, username, and password, a classic registration form, and how the user is going to retrieve the elements to understand which is the correct input for the password, for the username, for the email, because of the label, because of the placeholder. Okay. If you are going to test the registration form through retrieving elements with the data test ID, if something won't happen, if you're going to remove by mistake the labels and the placeholder, the registration form is completely white, and the users are not able to register because they don't understand what they have to write into those input fields. But the tests pass because they are able to write into the input fields, retrieving them by the data test ID. Another reason is that using the data test ID gets into the way of debugging tests, because if a test is failing because you can't retrieve an element from the page, and the element is retrieved through data test ID, you have 3 possible sources of problems. The element that you're trying to retrieve has no more the same data test ID attribute at all. The element has the data test ID attribute, but it's wrong, it's changed, okay? Or something else, okay? First of all, you have 3 possible causes of the problem. And also, in order to debug them, you have to launch the test locally. You have to open the test UI. You have to open the front-end application. You have to inspect the front-end application. You must check if your HTML element has or not the attribute or the correct one. Why? If you don't use data test IDs, if you use placeholders, labels, texts, etc., the same that the users use, if a test fails, And if a test says you something like, hey, I cannot retrieve the input element with the password placeholder, just with a screenshot of the test, you can understand the reason. Maybe now the password is called secret credential or secret key. Now the password input field has no more the placeholder, but has a label. So you have a problem. From a screenshot, you understand the reasons of the problem. You already have debugged your test. You know what is the source of the problem. Instead, if you use data test IDs, you're going to add friction to debug the test. So that's that's why I usually suggest not to use so much data test ID attributes. Usually, I suggest to use data test ID attributes for sections like header, sidebar, footer, registration form. In this case, it's fine because if you try to retrieve an element like, hey, I want to retrieve something with the register string and click it. You're thinking about the button, but maybe you have a lot of register strings in the page. Okay, so if you use a data test ID to say something, hey, please, inside this element with the data test ID registration form, please retrieve an element with the text register. Because I know that inside the form, I just have the button with the register string, and so I can click it.
Okay, got it. Thank you. And another question, you didn't mention it, but have you folks used some parallelism of your tests?
Yep, we use them, and we were used to split the Cypress tests into 8 different jobs that were run in parallel, and that's why we had to wait only 10 minutes for the endpoint test, because all the endpoint tests took more than 1 hour. And by splitting them, by parallelizing them, we were able to cut down this time. Again, as you said, as you can see, unfortunately, we don't have any value from the endpoint test, but yes, we use parallelism. Now I disable parallelism because we don't need parallelism with just 10 endpoint tests. And also, again, it's a complexity that at the moment we don't need it. At the moment, I mean.
I was asking because in my company, we have faced some issue because of trying to optimize testing. Using it, we faced some issue. That's why I asked if you got some issue using it.
Yeah, no particular issues. If the endpoint tests are implemented correctly, I mean, they are independent. They create the application state that they need, and they clear the application state after being run. So you don't have problems with application state. Again, usually, because it really depends on your use case.
Okay, thank you. I see a question from Simone.
Yeah.
Simone, do you want to say it yourself?
Yeah, okay. Yeah, so I wonder why you prefer skipping flaky tests over having them run anyway, because I think, like most of the flaky tests happen due to either slow API responses or Cypress executing commands too fast.
Yep.
So I think flaky tests also help you, spot slow endpoints or other minor flaws.
Yeah, my suggestion is, let's say, it's true that thanks to the flakiness of the endpoint test, you can understand what are the problems in your system. What I suggest is flaky tests allow you to find out discrepancies and problems in your system, then fix the problems or fix the tests. My suggestion is only not if you know that the test is flaky because of other reasons, a lot of reasons, don't leave this flakiness there, because you're going to pay for this flakiness. You are going to maybe need again to relaunch the same CI again. You need to relaunch a job. You need to pay for this. You time by time, other people that are not maybe so much involved in your test. For example, if you are a front-end developer, also the server folks need to run the end-to-test of the front end into the CI. But they are going to hate it, because if you don't retry the same tests, they are going to be blocked a lot of times because of your tests. If instead you enable retry, I mean, why do you want to keep there your flaky tests? That's why my suggestion is, you have flaky tests, fix them now. If you can't fix them now because you don't have time, because the root cause of the problem is something not so easy to fix, etc. Okay, it makes sense. You need 1 more month of development in order to fix that. It makes sense. Skip this test for a month and leave a long comment explaining why you're skipping it and when theoretically you should be able to restore this test. So if maybe in the next month you're going to completely forget about the test because you have other priorities, and 1 year later I jump onto the code base and I found your comment, I think, okay, maybe Simone wanted to enable tests, but he completely forgot about it. Okay, let me check the issue that he linked, the API that he linked, the explanation that he linked, so I can check if I can now re-enable the test. My suggestion is, fix the flakiness now at all, or skip the test. Don't leave the flakiness there. Obviously, I'm not speaking about 1% flakiness, okay? If your end-to-end test sometimes fail, it's in the nature of the end-to-end test, okay? But I'm speaking more something about, like, also, I don't know, 20% of flakiness for 1 test, or even more. And if you have 50 tests, and inside these 50 tests, you have 10 tests that 20% of the time they fail, more or less, your CI every time fail because of this flakiness. So in this case, my suggestion is, if you can, please spend your time fixing them so you keep the value of the end-to-end test and you don't have flakiness. If you can't, skip them. If, like happened in the console, in the Hasura console, you can't rework them, you can't fix them, and you keep them forever, in the end, after 1 year, in the case of Hasura, I mean, after 1 year, these tests have no more value. They are just to remember you that, hey, yeah, you should have been fixed them, but you can't remove them at all.
Yeah, that makes sense.
I hope that.
I mean, like it depends also how many times the flakiness happens.
Yeah. And that's why in Hasura I started tracking the flakiness, because the problematic, we had more or less 25% of the tests that always fail, always.
Okay.
Another 20% of the tests that fail at a rate of between 5 and 10%. I don't like it, but it's acceptable. And another 20% that was failing at a 1% ratio. I don't care about the 1%. Unfortunately, it's in the nature of end-to-end tests. You use a real front end against a real backend, they can fail.
Okay, that answers my question. Thanks.
Thank you for the question. Great one. Other ones? I see also a lot of fans from Replay. And I'm not here to sponsor things, but I'd like to really thank Jerry, Jason, Oliver, that are from the Replay.io team. Why? Because the end-to-end tests are extremely hard to debug. It's almost, I don't say it's impossible, but it's very hard to debug end-to-end tests. And the only reliable way that I found to debug end-to-end tests is to using Replay.io. And I don't know if you know this product. I'm going to send the link here. And if you don't know Replay allows you to record a browser session and to replay it. But for record, I don't mean recording a video. I mean recording whatever happens into the browser. And that means that you can launch another time the same browser that loads the real front-end application, that performs the same request to the server, and obviously the JavaScript application, the server responses are all embedded into the fake recording. But again, it's not a video. It's a true browser session, completely recorded. And you can also obviously play with this session, but also add console logs, and you can completely debug your browser session after it happened. You can add more console logs. You can use the debugger you used to do, etc., etc., etc. So, Jason, Jerry, Oliver, if you want to say something, but again, if you need to debug and test, now Replay supports Playwright and Cypress, if I remember correctly, and it's the best way to debug and test in general. So I'd love to thank them because they spent a lot of time with me helping us with the Hasura and tests.
Thank you for that plug. Yeah, Test Cafe works as well. Any Chrome browser-based test runner should work.
Cool, thank you.
I really love Replay as a product. I think it's one of the best products of the decade. But again, I'm stopping sponsoring Replay now.
Any other question to Stefano, guys?
Okay, that's cool.
All right, we will have another meetup, sorry, meeting. I'm too focused in work. We will have another meetup next month. I will publish next week's. The host will be Thomas Shipley. I don't know if you know him. He is a QA in that case. We have hosted him some time ago. He's a really nice guy. If you are interested, feel free to reach out, and the video recording will be also published in the meetup later. Thank you, Stefano. Really, thank you. Thank you, folks, for attending.
Thank you so much, and feel free to reach out to me too if you want help, if you have questions, or if you need help to train front-end developers with front-end testing. That is usually the topic that I teach a lot of times. That's all. Thank you. It was a pleasure to be here. Thank you so much, Aurélien, for inviting me.
Thanks, guys. See you later.
See you. Bye-bye.
Bye.